Hello, this video is about algebraic division. It follows on from the last couple of videos on partial fractions. In those videos we were having a look at some expressions, so polynomials, we're doing a division, and in all of the cases that we looked at we had the degree of the polynomial, so that's the highest power of x that I've got in the expression. So in this case I've got an x cubed term, so my degree is 3. The degree was always higher than in the numerator. So in this case I've got an x squared term, so I've got a degree of 2. This video we're going to have a look at some expressions where that's not true. So expressions like this one, so in this case I've got the cubic term in the numerator, so degree 3, but I've got a degree 2 in the denominator. Similarly, if I've got the same degree, so in this case I've got x squareds in both expressions, so my degree of those polynomials 2 in both cases. So if the degree is the same, or it's higher in the numerator, you can't use your partial fraction techniques. We need to do some algebraic division first. There's a couple of different methods that we can use. One of them is equating coefficients. That method is described in the textbook. It's also in the notes that accompany the video. So have a look at that one. I'm going to concentrate on, in the video, on the other technique, which is known as algebraic long division. Now, it's an extremely powerful technique. It's really useful to us, but it does take a while to get a head around, so I think it's worth seeing that demonstrated. Right, first things first, let's start off with, rather than an algebraic long division, let's start off with a normal long division, because I'm sure you're probably all a bit rusty on how that works. Most of the time, when we're doing our division with numbers, we're probably going to use bus stop, short division. We probably haven't seen long division for a while, so let's give ourselves a bit of a recap on how it works. So I've got 41,477 and I'm dividing it by 12. So first of all I'm working out how many 12s go into 4. Right, so that is 0. So how many 12s are going to go into 41? That's going to be 3. So 3 lots of 12 are 36. The 36 I'm going to write underneath my 41. What I'm going to do then is I'm going to subtract them, and then I'm going to bring down my numbers as I need them. I find it's easier, as I've used my numbers, to cross them off. So the 41, take away my 36, is going to give me 5, and then I'm going to bring my 4 down. So I've used my 4, and I'm going to cross it off. So I then want to work out how many 12s go into 54. Well, 12s into 54, I reckon that's going to be 4, because that's going to give me 48. So I'll write my 48 in, and I'm going to do my subtraction, which is going to be 54, take away 48, is going to give me 6, and then I'm going to bring my 7 down. There we go. So bring the 7 down, I've used it, let's cross it off. So I now want to work out how many 12s go into 67. Well, that's going to be 5. So 5 12s are 60. And we can do the subtraction, we're left with 7. We can bring down our final 7, so let's cross it off. We've used all our numbers at the top now. How many 12s in 77? Well, that's going to be 6. 6 12s are 72, and that's going to give me a remainder of 5. So what have we done? Let's write it down here. We've done 41,477 divided by 12 is equal to 3,456 plus my remainder 5. What did we divide into it? Are they? They're 5/12. Okay, so we've done the long division. One of the things is really important. You can see what I've done. I've made sure that all of my figures are always lined up all of the way through. It really does make a big difference to your accuracy if you're just careful. It takes a little bit longer, but your accuracy goes up massively if you're really careful in how you lay out the division. Okay, so that's one with numbers. Let's have a look at one with some algebra. I am going to divide x plus 1 into x cubed plus 4x squared plus 2x plus 3. Again, I'm going to be really careful in how I lay this out. It's the same technique that we just used with the numbers that we're going to use for our algebra. First things first, I want to work out how many x's go into x cubed. So I've got one lot of x into one lot of x cubed, so that's going to be x squared. And then I'm going to multiply that x squared by the two things outside my division line. So x squared times x, it gives me x cubed. These are the same. So if I've got this right, these two should be the same, so they cancel. X squared times 1 is one lot of x squared. In the same way with my numbers, I'm lining up my x cubes, I'm lining up my x squareds, I'm going to be lining up my x's, and then I'm going to line up my constants. So what have we got? X cubed take away x cubed, that disappears, that's good news. 4x squared take away 1x squared is 3x squared, and I'm going to bring my plus 2x down. So I've used that, and I've just brought my 2x down. X plus 1 I now need to divide into 3x squared plus 2x. Well, how many x's go into 3x squared? Well, that's going to be 3x. So 3x times x gives me 3x squared. 3x times 1 gives me plus 3x. And we're going to do the subtraction. 3x squared take away 3x squared, that's going to cancel. 2x take away 3x is going to give me minus x. Then I'm going to bring my plus 3 down. Almost there, but not quite. Because my x plus 1 term, I can still divide into minus x plus 3. So how many x's go into minus x? Well, that's minus 1. So minus 1 times x gives me minus x. Minus 1 times plus 1 gives me minus 1. Do my subtraction. Minus x take away minus x, that's going to cancel. Plus 3 take away negative 1 is going to give me 4. So I've got a remainder of 4. So what have we done? We've done x cubed plus 4x squared plus 2x plus 3. And we've divided it by x plus 1. And it's equivalent to whatever we've got on across the top. X squared plus 3x minus 1. And we were left with our remainder 4. For what? Well, we were dividing by x plus 1. 4 divided by x plus 1. And we've converted this pretty horrible fraction into polynomial and a very simple fraction. Why have we done this? Well, if I wanted to integrate this expression on the left, really difficult. Very, very hard. But have a look at the terms we've got on the right hand side. I can integrate x squared, I can integrate 3x, I can integrate minus 1, and I can integrate 4 over x plus 1. So this is really easy to integrate. This is rock hard. So we've taken something that's really complicated, we've made it into something much simpler that we can now integrate. Okay, one final example. We have got this time, we've got x squared minus 1, and we're dividing it into this quartic expression over here. So I've got an x to the power 4, cubed, squared, an x, and a constant term. I haven't got an x in here. I need to be really careful, and this is where it really helps to make sure that you're lining up your powers of 4s, cubes, squares, x's, and your constants. If you do that, far less likely that you'll make a mistake. If you don't, guarantee it'll go wrong somewhere. Right. Same approach as before. How many x squareds go into 3x to the power 4? Well, I reckon that's going to be 3x squareds. 3x squareds times x squared is going to give me 3x to the power 4. I've got 3x squared times minus 1, so I've got minus 3x squareds. I've got no cubes, so I'm going to leave a gap. But I've got minus 3x squared. I'm going to use my division line there. So I'm going to do the subtraction. 3x to the 4, take away 3x to the 4, that's going to cancel. I'm going to be left with my 3x cubed in here. And I've got 2x squared, take away negative 3 lots of x squared, so that's going to give me plus 5x squared. And I'm going to bring down my x. So I've actually used all 4 of those terms. Right, how many x squareds go into 3x cubed? So that's going to be plus 3 lots of x. So 3x times x squared is going to give me 3x cubed. 3x times minus 1 gives me minus 3x. Nearly made a mistake myself. Haven't got any x squareds. So nothing in here. I've got the 3x. It needs to line up with my x's. And I can do the subtraction. So 3x cubed, take away 3x cubed, cancels. I've got 5x squared. I've got plus x, take away 3x, so that's going to give me plus 4x, and I'm going to bring my plus 3 down. So I've used that plus 3 up. So, how many x squareds go into 5x squared? Well, I reckon that's going to be plus 5. So 5 lot of x squareds, 5x squared, take away 5. Again, I've got no x terms. Let's do the subtraction. Right, x squared terms cancel. I'm left with 4x plus 3. Take away negative 5 is going to give me plus 8. X squared's not going to divide into x's. So this is going to be a remainder. So what have we got? We have got 3x to the power 4 plus 3x cubed plus 2x squared plus x plus 3 all divided by x squared minus 1, and it's equivalent to expression across the top, so 3x squared plus 3x plus 5, and then we had our remainder, which was 4x plus 8 divided by a denominator here of x squared minus 1. So I've taken something pretty horrible. I've now got a polynomial, degree 2, I've got an x squared term, and I've got a partial fraction over here. The degree of the denominator, 2, is greater than the degree of my numerator, which is 1. So if I wanted to, I could convert that into 2 partial fractions, but more of that in the next video. Okay, time for a little bit of practice. So you should have some instructions in terms of the exercise to try to get a little bit of practice in. Thank you.